Hello students, in this video we are going to discuss Cbse class 9 maths chapter 8 quadrilaters. Today we are going to see an important theorem, theorem 8.9, that is the midpoint theorem. Okay, we are going to see about the midpoint theorem. So what is midpoint? Midpoint, you can call it as a center point. You have a line abdina, the center point of the line, you call it to be a midpoint. Okay, so we are going to learn about this midpoint theorem. So let's get into the statement of the theorem. The line segment joining the midpoints of two sides of a triangle. So here we are going to consider a triangle ABC. Okay, let me name this triangle A, B and C, and we are going to consider the midpoints of the two sides. So two sides here it is going to be AB and AC, and the midpoints you are going to consider it to be points E and F. Okay, so the line segment joining the midpoints, that is the line segment is what? This is your line segment EF. Okay, and joining the midpoints of the two sides of a triangle is parallel to the third side. What is the third side? BC. So what they are telling is that they are asking us to prove that EF is parallel to BC. Okay, so what are we given here? We are given that we have a triangle ABC, and we are given that E and F are the midpoints. E and F are the midpoints of AB and AC. So all these are given, and we are asked to prove that EF is parallel to BC. Okay, so this is what we need to prove. So in order to prove, what we are doing here is we are going to do a small construction here. Okay, and the construction is that we are drawing a line from C which will be parallel to AB. We are drawing a line C which will be parallel to AB, and we are extending the line EF to this line such that it meets at D. Okay, so from this we can say that your CD is parallel to AB. So we are drawing a line. Okay, so draw CD parallel to AB, and we are going to join FD. Got it, children? So this is our construction here. So this is only our construction. So this is about the statement and what we have to prove and what we are doing in the construction part. So now we can observe these two triangles, triangle AEF and triangle CDF. So before we do that, we see that AB and CD are parallel. So if AB and CD are parallel, then we can say that this line ED is a transversal. ED is going to be what? A transversal. ED is a transversal. So if this is CD abdina, then this will be AB. Okay. So in that case, we can say that these angles are going to be equal. Which angles will be equal? This angle will be equal to this angle. So all these will be equal. So that we will do it in detail by drawing it separately again. Okay. So we have the triangle ABC, midpoints E and F, and we're joining it to a point D. So let us consider the triangle AEF and triangle CDF. CDF. Okay. So as we discussed now, we have this to be AB. Okay. And here you have CD. Okay. So you have E somewhere here. So in this you can say that the angle AE from here, that is the angle AED. Okay, AED is AEF, everything you can say it's equal only. Okay, so when this is going to be transversal for this, you can talk about this angle and this angle, isn't it? So this angle and this angle will be equal, isn't it, children? Yes, so this and this will be equal because these are going to be alternate angles in a transversal. Okay, so here vertically opposite and angle AEF. So this angle is equal to what? Angle CD and F. So CDF. Okay, so these two angles are equal. Likewise, these two will also be equal. So we can say this angle F will be equal to angle F here again. Okay, so from this we can say that these triangles AEF and triangle CDF are congruent. So these two triangles are congruent. If they are congruent, we can also say that EF is equal to FDF because they are two triangles are congruent, then your sides will be equal. So your EF will be equal to DF. Likewise, we already know that E is a midpoint. So what do we know is that your AE is equal to what? BE. Your AE is what? BE. Likewise, you can say your AE is equal to CD. AE is equal to CD. So where you can also say it is going to be equal to BE. Got it, children? So AE and CD are equal and we already know E is the midpoint. So AE will be equal to B. So these two will also be equal. So now look at this diagram BCDE. Look at this quadrilateral BCDE. So from this what we can say is that your BE is equal to CD. So what is equal? Opposite sides are equal and parallel. Opposite sides are equal and parallel. So we know that if the opposite sides of a quadrilateral are equal and parallel, then we can say that it is a parallelogram. Isn't it, children? So from this we can say that it is going to be a parallelogram. This you can see in your theorem 8.3. If each pair of opposite sides in a quadrilateral are equal, then it is a parallelogram. So therefore, we can say that BCDE is a parallelogram. BCD is a parallelogram. If BCD is a parallelogram, then we can immediately say that your ED will be parallel to BC. If ED is parallel to BC, then we can also say that EF is parallel to BC, isn't it? So EF is parallel to BC. So this is what we need to prove, isn't it, children? So we need to prove that BC is parallel to EF, so that we are able to prove. Now let's do a quick recap. So we are considering a triangle ABC. So for this triangle ABC, we have the midpoints of two sides to be E and F. And as a part of the construction, we are drawing a line parallel to AE, which will meet EF at D. Okay, we are extending it to meet it at D. So from this, we are considering the triangle AEF and triangle CDF. So from this, we are able to prove that this angle and this angle are equal. Likewise, you are able to say that this is equal to this. So your angle E is equal to angle D. F here is again going to be equal to angle F here. So we can say that these two triangles are congruent. If they are congruent, the sides are also equal. So your AE is equal to CD. AE is equal to CD means we also know AE is equal to BE. Clear? Yes. So likewise, we know that when these two are congruent, EF is also equal to DF. So EF is equal to DF. So with this, we are able to say that these two are parallel also. So if the opposite sides are equal, that is your BE is equal to CD. That by the theorem 8.3, we can say that your BC DE is a parallelogram. BCDE is a parallelogram. So from this we are able to prove that this EF is parallel to BC. EF is parallel to BC. So now this line segment joined in the midpoint is what? EF. Parallel to the third side is what? BC. Have you proved? Yes, so thus we can write hence proved. Is it clear, children? Yes, same thing is given in your textbook also. Please go through it. Here they are giving us a diagram here. Same thing only we drew even to explain. So E and F are the midpoints of AB and AC, and respectively we are drawing a line CD parallel to AB. Okay. So as per the angle side angle rule, we are able to prove that these are congruent. Okay. So your AEF and CDF, it is going to be congruent. So then with that we are able to say these two are equal, and thus BCD is a parallelogram. Thus we get EF is parallel to BC, hence proved. Is it clear, children? Yes. Hope you understood this theorem. See you again another video with the next concept. Okay. Thank you, children.